Thank you. Thank you, organisers, for inviting me to speak. Environment perspectives. But I'm going to start with you back. Biogeography, the importance of species richness, of work we now really can think about or the physical connections, so corridors between, but also the functional connections, patches, and the size and distribution of patches conditions in those. It's clear that connectivity is now central to our modern philosophy for conservation. From terrestrial and freshwater environments, including the coastal. And this, and of course we can apply a lot of this experience, our learnings on the principles to the marine environment, but we need to make sure we understand the contextual differences at sea if we're to make the right decisions for conservation, both in the fully marine environment and where conservation needs to work across that land-sea interface. And for me, these contextual differences start with understanding the differences in the relative history of habitat loss between land and sea. Because habitat loss and fragmentation, of course, is a key driver for impacts on connectivity. And yes, of course, we have lots of damage to marine habitats, and some of those damages are very widespread. And yes, we have habitat loss, especially in some nearshore and estuarine habitats. But in general, and I stress this as a generalization, one of a few I'm going to make, the extent of habitat loss at sea has been far less than that on land. And that largely reflects the distribution of human populations in cultivated land. Another important difference is the practicalities and costs. Oh, my screen's gone blank. Thank you. Practicalities and costs in conservation of different environments. On land and freshwater, a lot of the conservation we do is about restoration, and that includes lots of coastal examples, some of which we've heard about already. That restoration is mimicking or replacing habitats or processes, including those relevant to connectivity. To a large extent, this reflects the history of habitat loss, but also the feasibility of doing restoration. We can do wetland and peatland restoration. We can plant native woodlands. But at sea, even where restoration is desirable, it's often too expensive or impractical, or we just straightforward don't know how to do it. There are some exceptions to that, of course, and especially in the nearshore and the intertidal environments, such as seagrass beds and native oyster beds, and we should encourage that sort of restoration where we can. But for the most part, what this means is that while on land and in freshwater we are often managing the environment, at sea, where most of the time we're managing the pressures on the environment. And so this means that we can, or at least we should, be trying to be proactive or preventative rather than reactive and restorative in marine conservation. But the biology and ecology of marine species is also very important here because it has big implications for our understanding of its connectivity, how it can be impacted, and what the best options are for conserving it. Take, for example, what we know about, in a general sense, the reproductive and dispersal strategies of marine species. Most marine benthic species, most marine invertebrates, and most marine bony fish have very high fecundity and pelagic dispersal. Propagules transport over large distances, and so their gene flow has a big spatial scale and they have very open structure to their populations. Then when we look at higher trophic levels, like seals and seabirds, we're typically seeing large foraging and migratory movements. So, for example, the connectivity between breeding and foraging habitats can take place over huge expanses of sea. But these things really relate quite closely to the dynamism of the physical environment itself, the fluid environment in which these live, which is very important for marine ecology because it creates conditions for dispersal and transport and variability in space and in time that marine population dynamics, response rate of populations to impact. To wrap these things into kind of one statement, I think we can say that in general terms, marine ecology has a high degree of openness, an openness that is experienced by relatively few terrestrial species. And this really lends itself more to this functional variety of connectivity rather than structural connectivity. And from that, we can suppose that, well, perhaps a lot of marine ecology is less sensitive to habitat fragmentation. Again, this is a big generalization. There are lots of exceptions to this, many of which we're hearing about. And there's still, of course, lots to be gained by conserving that functional connectivity. But if we're to conserve that connectivity, we need to understand it. And the state of affairs is that we don't have as good an understanding of ecological connectivity at sea than we do on land. And this largely comes down, again, to the practicalities and the costs of survey and research at sea. And that's a reflection of the things I've been talking about already, the openness, the variability, the spatial scales, and the sheer physical variability and dynamism. But there are some good examples, and these are increasingly aided by technology. So when we look at how we apply this to marine species, there's things like there's lots of tagging projects, satellite tagging of marine megafauna. And for smaller species, there's increasing use of techniques like stable isotopes and other geochemical tracers. I'm not going to talk through examples in particular detail because we're going to hear lots more about examples through the course of the day and tomorrow. Instead, I'm going to talk a bit now about, in generalities, about research opportunities and how they relate to particular applications. And starting with MPAs, because MPAs, of course, have, for some species, an important role in supporting connectivity, whether that's in relation to larval transport or gene flow, for example, across an MPA network. And there's been quite a lot of work on that sort of thing in other parts of the world, but in Scotland, for example, I think research can start to ask more questions about whether the size and location of our MPAs is right, if there's things that could be done to improve the management of them. This connectivity question could be taken from a different approach as well. We could look at whether those sites are helping adaptation of species to climate change. And the second one I have here is about connectivity with fisheries benefits, because where an MPA supports fisheries species or the habitats that are relevant to them, if they're protected either deliberately or incidentally, it's of course always helpful for us to be able to demonstrate those benefits and to demonstrate that MPAs can be part of a positive approach to fisheries management. And then of course there's all the opportunities that are to do with the exceptions to the generalizations I've been making. We'll hear more about some of those, I'm sure, but things where we know there's been habitat loss, or we know there's an achievable route to restoration, or where we've got species with a less open ecology or a site fidelity. And that site fidelity could be throughout its life or in particular life history stages. Those are all relevant to MPA applications. But there's more to marine conservation than MPAs, and in Scotland in particular we have a very strong policy context for doing more marine conservation in what we're calling the wider seas. And that can cover a whole selection of things, but includes how we license development activities and the conditions we place on those, and also the management of other activities like fisheries or shipping, recreation or tourism, among many others. And examples of the kinds of research that could be done that would help us deal with those things are, for example, some of this work on the connectivity of mobile species with pressures. So some of this work on satellite tracking and tagging can help with that. But we're also looking to research to help us get a better handle on the thresholds or condition targets for maintaining functional connectivity at this seascape scale and at this wider sea scale. And that can be to do with habitat distribution or quality. It could be about species demographics or physical processes. And these can be taken in different contexts as well. So we can be looking to avoid or mitigate impacts, or this work can help us support the adaptation of species to climate change or the delivery of ecosystem services. I've talked about these things under the umbrella of wider seas, but because it's my particular area of work at the moment, I'd also like to mention them under the bigger umbrella of marine planning. And this is a useful mechanism for conservation because it's intended to be an integrated and ecosystems approach to all sectors and all interests and all regulatory mechanisms. And so it presents a great opportunity to incorporate information on ecological connectivity at the seascape scale and to inform how we manage developments and activities and conservation, all of them together in the round. It should also allow us to work with socio-economic interests for long-term mutual benefits, so that we're not just managing impacts on connectivity, but so that we're also supporting connectivity between ecosystem services and the benefits humans derive from them. And finally, marine planning should also help us to make the ecological and ecosystem service connections across the land-sea interface, because it should enable a more joined-up approach to conservation across these realms. And these are opportunities which I think marry well with the principles we've been talking about this morning for seascape ecology. So looking forward to the rest of the afternoon, I'm hoping I'll be able to look back and reflect on the applications of what other people are talking about in relation to marine planning in particular. That's me.
And time for a couple of questions. Any? Richard?
That was great. And as Jonathan said at the start, I was really keen for this conference to happen. And your presentation kind of summed up for me personally why I was so keen. Because you're translating those ideas from landscape ecology to marine environment. I think the question for me, though, from your presentation